I'm going to go over the examples to the practice where you have to distinguish between ionic and covalent compounds, and in this situation, write their formulas. So let's look at number one. In number one, we need to determine if it's ionic or covalent. So as you look at the periodic table, you're going to notice that sodium is a metal. As soon as you know that it's a metal, because remember, ionic compounds, if you have a metal, it's going to automatically be ionic. So I'm going to put an I for ionic here. And so the other thing, when you notice it's ionic, is we're going to cross charges. So I'm going to write this symbol for sodium, go to the periodic table and look up its charge, write iodine, go to the periodic table, record its charge. Then I'm going to cross charges. So remember, when you cross charges, you bring those charges down to become subscripts, and my final answer is NaI. Nitrogen trifluoride. You'll notice here that you have a couple of things going on. Nitrogen and fluorine are both nonmetals, and anytime you have two nonmetals together, it's immediately covalent. The other indicator is that you have a prefix, tri, and anytime you have a prefix, it's going to be covalent. So I'm going to indicate that it's covalent. I am never going to look up charges or cross anything, but instead, the prefix is going to communicate the subscript to me. So I'm going to have nitrogen, and then trifluoride, so I'm going to write down fluorine, and the tri prefix indicates that it's 3, so I'm going to write NF3. Number 3, strontium fluoride. So again, we're going to look up the types of elements these are on the periodic table. Strontium is a metal, and if I have a metal, it's going to be ionic. So I'm going to indicate that in the box. And for ionic, I'm always going to cross charges. So let's go to find strontium's charge on the periodic table. It's a +2. Find fluorine's charge on the periodic table. It's a -1. I'm going to cross those charges, and I'm going to rewrite it to look beautiful. SrF2. Looking at number 4, lead 2 sulfide. So I need to look up lead on the periodic table. It is definitely a metal. Remember that tin and lead are those two elements that are not transition metals, but they do need Roman numerals. So because I have a metal and I have a Roman numeral, I immediately know that that's ionic. So the symbol for lead is Pb. Remember, the Roman numeral tells you the charge. I'm going to look up sulfur on the periodic table. Its charge is a -2. Now, one of the things you're going to notice is that you have that +2 and the -2. Those are going to cancel out, and so when you write your final answer is going to be an empirical formula. So remember that we do use empirical formulas for ionic compounds. So if possible, we're always going to use an empirical formula, and it is possible in this example. So my final answer is going to be PBS. Next, silicon tetrafluoride. Remember that for covalent compounds, if you have carbon and silicon, they are always going to share their electrons, and so this is definitely going to be covalent. You can also notice that silicon is to the right of the zigzag line. Another indicator is that I have a prefix. So we're going to write down the symbol for silicon, and then tetrafluoride. The tetra indicates the subscript of fluorine is a 4. Notice how I did not look up any charges. There are no charges because covalent compounds don't have any cations and anions. They're sharing their electrons, so don't look up any charges. Number 6, iodine pentafluoride. So a couple of indicators. Iodine's a nonmetal, fluorine's a nonmetal, and I have a prefix. This is definitely covalent. So I'm going to write down the symbol for iodine, the symbol for fluorine, and notice how there is a penta prefix. Penta means 5, so I'm going to write down a subscript of 5. Number 7, silver 1 carbonate. So things I'm noticing, silver is a metal, and it has a Roman numeral because silver is a transition metal. So I immediately know that this is going to be ionic. So I'm going to write this symbol for silver. And remember, for ionic compounds, I'm always going to cross charges. So the Roman numeral tells me the symbol for, or the charge of silver is a +1. Carbonate is a polyatomic ion, which is another indicator that this is definitely ionic. So we need to look up carbonate on our periodic table. Carbonate is not the element carbon. It is the entire polyatomic ion. So now when I cross charges, I'm going to cross this 2 to come over here. Now remember, when I cross charges of 1, I do not write a subscript of 1. So because that subscript is understood, I do not need parentheses around the polyatomic ion. So my final answer is Ag2CO3. Number 8, magnesium sulfate. So things I'm noticing, magnesium is a metal, so it's definitely ionic. Sulfate is on my list of polyatomic ions, so it's again definitely a ionic compound. So let's indicate that it's ionic. We're going to write down the symbol for magnesium and its charge. Sulfate, I'll look up on my list of polyatomic ions. All right, what do you do when you have a +2 and a -2? All right, so those cancel out, so that means it's an empirical formula. And when I write my final answer, I do not need subscript or parentheses around the polyatomic ion because there was no subscript crossed to the outside of it, so it's just MgSO4. The next one, number 9, ammonium chloride. All right, if you take a moment and try to look up ammonium as an element on the periodic table, you'll notice it's not one of the 118 elements. So what does that mean? It means that it's a polyatomic ion. So go to your list of polyatomic ions and you'll find it there. Chlorine is also an negatively charged element. So because ammonium is a cation and chlorine is an anion, this is going to be an ionic compound with a cation and an anion. So because it's an ionic compound, we are going to cross charges. So we're going to write down the formula of ammonium from our list. There's that cation. And chlorine, we're going to look it up on the periodic table, its charge is -1. Now notice what happens here. The +1 and the -1 also cancel each other out. So because I'm not crossing any subscripts, I do not need parentheses around that polyatomic ion. So my final answer is just NH4Cl. And I forgot to indicate that was ionic. All right, number 10, beryllium hydroxide. So let's go to the periodic table. You're going to notice that beryllium is a metal. Hydroxide is not hydrogen. It is a polyatomic ion. So because you've got a metal and a polyatomic ion, this is definitely ionic. So I'm going to go ahead and write down the symbol for beryllium and its charge because we always cross charges for ionic compounds. Hydroxide is on my list of polyatomic ions. Now some people get very confused if they should put parentheses here. The answer is definitely yes. Notice that you're crossing a charge to the outside of that polyatomic ion. If you don't put parentheses around it, you're saying that the formula of hydroxide is OH2. That's not correct. So because you're crossing a charge to the outside of that polyatomic ion, you must have parentheses. And of course we do cross the 1, but we don't write subscripts of 1. So our final answer is BE parentheses OH, close your parentheses with a 2 on the outside. Last, we've got sulfur tetrafluoride. So things I'm noticing, sulfur is a nonmetal, fluorine is also a nonmetal. So 2 nonmetals together is covalent, and I have a prefix. So I know it's going to be covalent. Remember, there are no charges with covalent compounds, so I'm not going to look up any prefix or any charges. I'm just going to have sulfur, and fluorine, tetra, indicates a subscript of 4.